Oh, hey everyone, I didn't see you there. Well, next up with our online learning is going to be one of my favorite topics, the conic sections. The conic sections are actually two-dimensional shapes that you get from cutting a three-dimensional cone. And when you study a little further, these two-dimensional shapes actually have equations, rather complex math equations, but equations involving x and y and all kinds of other functions that will create these conic sections, that will create these two-dimensional shapes. Now, since these conic sections come from cutting a cone, first we're going to need a cone. Well, that's not quite what I was thinking. And that sure looks delicious, but not quite what I was thinking either. Can someone please just give me a regular cone? Okay, yes, there we go. So if we have a three-dimensional cone and we start cutting it...
The Greeks knew the parabola and the hyperbola, as well as the ellipse. By slicing a cone with a plane, they generated curves called conic sections. If the cutting plane is perpendicular to the axis, it cuts out a circle. When the plane is tilted, the circle becomes an ellipse. Tilting it enough for the plane to be parallel to a side of the cone produces a parabola. Tilted farther, the conic section becomes a hyperbola.
So we have four different types of cuts. If you look again at the cut shown in red, that would be parallel to the base of the cone. And of course, that's going to make a circle. If you take a look at the yellow cut, that is made at an angle. And that would make an elongated circle known as an ellipse. Now, the green cut is parallel to one of the sides of the cone. And if you cut parallel to the side of a cone, you get a perfect parabola. And then finally, there's the hyperbola, which actually requires two cones that are sliced. Now, if we had been in class, I have these cutouts shown here with these four different colors actually for you to hold in your hands. And so the two-dimensional shape that you get from cutting a three-dimensional cone, again, it creates a conic section. Now, we've actually already studied circles. Remember, the equation for a circle is x squared plus y squared equals r squared. So we actually already studied the first conic section, and what we're going to do is we're going to jump in and learn the equations for the other conic sections and see that although they look quite complex, that all of these letters, from x's and y's to h's and k's to a's and b's, all relate to understandable parts and features of each of these graphs. But first, we're going to start with the parabola, and we're going to learn that a parabola is more than just y equals x squared. Now, once we figure out parabolas, well, then we'll move on to ellipses, and you'll find out that ellipses involve a fraction, and the denominator of those fractions has a lot to do with the particular orientation and size of the ellipse. And then when we're near the end, we'll be looking at hyperbolas. In fact, you'll find out that you actually will teach yourself hyperbolas. That is, you will end up using the ideas that you learn from parabolas and ellipses to really just make the next connection using the guided note sheet, again, to learn hyperbolas. So we're ready to begin. Now, as I mentioned a few times in the video, there's going to be a certain expectation for you to learn and gather some of this information on your own. Had we been in class, I would have given you this starter slide to help you start to understand parabolas. What I would actually like you to do is, as it says here, do some reading. Start on page 632 and move over to 633 and be able to fill in some of the notes that you see on your parabola note guide. Now, fill these notes in, and then what I will do is be here in the next video to help you start to learn these ideas. But I just want you to preview them and actually write them down on your own. So you actually want to do that now. Don't just start up the next video. Gather some information, write down some notes, start to get a little bit of an idea of what's going on with parabolas.